Hello everyone. Hello everyone. Good evening everyone. Thank you so much for joining everyone. So this is your educator Debasish. I'm a plus one verified educator in the IIT JAM category and welcome you all to the channel IIT JAM Unacademy. So today we are going to discuss about a topic that is on nerve impulse conduction. Right. So guys, this is going to be a very interesting topic. So just hold on a moment. There is a technical issue. So that there will be a little delay, right? So I hope you guys will can hear me, and if at all you have any doubt you can tell me. Okay, so guys, before starting this session, I have introduced myself, and let me tell you, please subscribe the channel so that you will get all the updates and your preparation will be in a good place, right? So can you hear me? Anyone is there? Can you please let me know? Can you hear me or not? Anyone is there? Okay. So the topic for discussion is not impulse conduction, right? So before going to the topic, I'm going to discuss some preface of this topic. So what we are going to study today, right? So as you all know, there are some ion channels are there. I hope you guys know that what is the ion channel. So these are the facilitated diffusion process, right? So to the ion channels there will be facilitated diffusion, right? So guys, in the, I know you know facilitated diffusion is a passive transport, right? So there is no need of ATP. I hope this thing is clear to everyone, otherwise I will take another class for this, right? So these ion channels are of various types. Like first one is your gated ion channel, and the second one is your non-gated ion channel, right? So as you all know what is a non-gated and what is a gated. In the gated ion channel, right? So there must be a gate. So without the stimulus, there will be no movement, right? In the non-gated ion channels, so there will be no gate. So it will be always open, right? So let me give you an example. So example is open potassium channel, right? So guys, what this potassium channel do exactly? So for an example, this is our plasma membrane. So let me draw a potassium channel. So what the potassium channel do? So for an example, this is our potassium channel. It will move out, it will efflux out the potassium to from inside to outside. So which is this phase? This is the cytosolic phase, right? And this is the extracellular phase, right? So what will be the relevancy of this thing? I will discuss in a moment, right? So there is a gated ion channel, and in gated ion channel, I'm going to categorize this gated ion channel into three parts. So there will be no movement of ions as gate closed, but they can open in response to stimulus. So what are the stimulus and how they are opened? I will describe in just a moment, right? So let's go to our next slide. So the gated ion channels. So gated ion channels are of how many types? Anyone? Anyone can answer? I will be very happy. So gated ion channels, anyone? So gated ion channels are of three types, right? So let me categorize. So let me right. The first one is your ligand gated channel. Second one is your voltage gated channel. And the third one is mechanical gated channel. Right. I hope you are getting all these things. So I am going to describe all these points. So now onwards. So first one is what? Ligand gated channel. So as the name suggests, it will open in response to a ligand. So what is the voltage? So there must be a voltage in the plasma membrane, right? We are talking about the plasma membrane because these ion channels are present on the plasma membrane. And the third one is mechanical gated channel. So what are the mechanical stimulus, right? So mechanical stimulus can be anything like touch, pressure. So these are the mechanical pressures which will open these ion channels, right? So let me write it for you. Yeah. So as I have already told you, ligand gated ion channels open with response to any ligand molecule, right? Second one is voltage gating channels open in response to change in membrane potential. So I will describe everything in a detailed manner. So be online and you will get everything. And as I have already told you, the mechanical gated channels open in response to mechanical or physical pressure, right? Study. So in this, let me give you an example where these are located and we are going to discuss all everything over here. Like it is present in the neurons, right? It is present in the neurons, and we are going to discuss about this thing only, right? And particularly in the dendrites and cell body. The voltage gated ion channels are present in neurons, but in the axon part. And the third one is in the skeletal muscle. So we are going to discuss about all those things, and this is obviously present in your skin, right, and your auditory system. So I hope these things are clear to you. One is ligand gated channel, voltage gated channel, and mechanical gated channel. So we are going to discuss about very intensely this ligand gated channel and this voltage gated channel in our discussion, right? So for an example, this is our plasma membrane. This is our plasma membrane, and how this gated channel work. So this is, for example, a ligand is bound to it. So this is a ligand, and the ligand can be what? So the ligand can be, ligand क्या क्या हो सकता है भाई? It can be acetylcholine, glutamate, etc. Right? There are a lot of, they're like glycine, GABA, epinephrine, norepinephrine, aspartate. There are some excitatory neurotransmitters. There are some inhibitory neurotransmitters. Excitatory neurotransmitters open sodium channels. Inhibitory neurotransmitters open what? Calcium channels. Right? I will definitely give you a glance about that. So, for example, before the binding of this acetylcholine, right? So the channel will be like this. This will be closed. So this is in a closed conformation, right? So this will be in a closed conformation. So before binding with the acetylcholine. So after the binding with the acetylcholine, so this is our channel, and it will be bind with our acetylcholine. So acetylcholine is what? Acetylcholine is nothing but it is a ligand, right? Okay. So after this process, this channel will be in an open state. The conformation will be changed, and this conformation will be moved to the close to the open state, right? Yes, yes, exactly. So in this process, what will help over here? This ligand, that will be acetylcholine or glutamate, etc. Right? So this ligand will help us to open this channel and in the influx of the sodium ion. Right? I hope these ligand gated ion channels is clear to you. So let me tell you another thing. These ligand gated ion channels can be worked as, so it can be a ion channel, and it can be a what? Receptor. So how this thing is happening, I'm going to tell you in just in a moment, right? So it can be an ion channel, it can be a receptor, right? So now our sole focus is on how these ligand gated ion channels and these voltage gated ion channels help in nerve propagation. So now we are focusing on nerve impulse conduction. So actually where this thing is takes place, first thing. So first thing is, for an example, you can say here is a neuron. So here is a neuron, right? And here is another neuron. Right. So this neuron and this neuron and this particular place, this particular position is known as, yes, exactly, synapse. So because there will be no cell to cell communication, here will be no cell to cell communication. So this place, so there is a process takes place. This is known as synapses, right? So this neuron, it is a preceding neuron, and there is a another neuron which will give the signal to another one, right? So what will it do? It will release some neurotransmitters. What? Some neurotransmitters like acetylcholine to these synaptic cleft, right? It is known as synaptic cleft, right? So it is going to, it is going to release some neurotransmitter, release of neurotransmitter. I don't know why it's not working. My pen tab is not working properly. Just hold on a moment. And these neurotransmitters will go and bind with the another neuron. So it is neuron 2 and it is neuron 1, and it is going to put some changes in the second neuron, and that will we will see in just in a moment, right? So let me tell you, the sodium ion will be more at outside always, and the potassium ion will be more at inside. So in a normal condition, that is called as, good evening Krishna, in the normal condition this is called as a resting membrane potential. So what is a resting membrane potential? What is a threshold potential? What is action potential? What is depolarization, repolarization, hyperpolarization? We will just see in a moment, right? So first thing is, let me tell you what is a resting potential. Resting membrane potential. So resting membrane potential, so I'm highlighting this so that it will be visible to you properly. So it is the potential on plasma membrane when the plasma membrane in resting state or unstimulated state, right? And what is the value of this? This will be minus 70 millivolt, right? It is derived from experiment, right? Second one is your threshold potential. So what is a threshold potential? So threshold potential is, let me highlight this so that it could be visible to you properly. Yeah. So the minimum amount of depolarization required to open a voltage gated channel. प्लीज रिमेंबर दिस, वोल्टेज गेटेड चैनल को ओपन करने के लिए जितना चाहिए उसको बोला जाता है, और ये होता है इसका वैल्यू -35 मिलीवोल्ट. अगर इतना, इफ एट ऑल दिस मच millivolt is there, this much membrane potential is there, then the voltage gated channels are open, right? Third one is your action potential. What is the action potential? So action potential, what is action potential? So it is the membrane potential where neurons release their neurotransmitters, right? I hope you guys are getting that. So next we're going to start with our, and the action potential will be how much? Anyone? It will be plus 50 millivolt, plus 50 millivolt, right? Clear. So these things are clear to everyone. What is resting potential? When there will be no stimulus, then it will move to a threshold potential. When threshold potential will reach, the voltage gated ion channels will be open, and the final one is your action potential, where the membrane potential, where the neurons release their neurotransmitters, right? So I hope these things are clear to everyone. So now let's move to our three things, like what is a depolarization, repolarization, and hyperpolarization. So depolarization, when the membrane potential will shift from more negative to less negative. For an example, what is our membrane potential? It will be -70. So when it will be shift from -70 millivolt to -60, -50, then we will call as depolarization, right? When hyperpolarization will occur, so in the membrane potential is shift less negative to more negative, right? From -70 to it will shift towards -90, -100. So we will call these as our repolarization. And what is, sorry, sorry, apologize. Repolarization is, yeah. So repolarization is membrane potential shift to more positive to more negative, right? So what is repolarization? For example, the membrane potential will be +70, for an example. So it will shift to -70, right? So it is called as repolarization. And what is hyperpolarization? Hyperpolarization itself, it will be, if at all, it will shift to less negative to more negative, -70 to -80, -100. So it is called as hyperpolarization. I hope these things is clear to everyone. So when it will shift to more negative, then it is called as hyperpolarization. When it will be less negative, depolarization, and positive to negative, it will be called as repolarization. So how this thing is going on, let me tell you over here. Right. So let's draw a neuron. So this will be a neuron for you, and you will get everything clear from this diagram. Please, yeah. So for example, this is our neuron. And I hope your parts of the neurons are clear to everyone. I know you was, I know, very okay. So this is our neuron, right? So in this neuron, so this is our nucleus. So when, let me draw another diagram. So it is our neuron 2, what we have already told you, and it is our neuron 1, right? So it is called as the presynaptic cell or presynaptic neuron, and another one is postsynaptic neuron, right? So which one is presynaptic, which is faster, which is present in the first position? So it is called as the presynaptic neuron. Is the presynaptic neuron, and it is your post synaptic neuron. Okay, so now what will happen? I don't know why there is this technical issue happen. Actually, after a long day, I'm taking this YouTube session. Okay, so it is our synaptic cleft, right? In the synaptic cleft, there will be release of neurotransmitters. Oh God, it's not working. Hold on a moment. Hold on a moment. Right. So neurotransmitter will be released over here. So then it will received by. So I have already told you the ion channels will act as they are the receptors and they are the ion channels. Right. So ligand gated ion channels have two properties that they can act as a ion channel, they can act as a receptor. So here in the dendrites, it will act as a receptor first, right? So when it will act as a receptor, when it will act as a receptor, so for example, I am just showing two receptor over here, right? When it will act as a receptor, so these neurotransmitters will go and bind with, oh my God, these receptors. So what are these? So these are receptors as well as sodium ion channels, right? So they will go and bind over here, and that sodium channel, they will open the sodium channel. Okay, so what was the membrane potential earlier? What was the membrane potential earlier? It was minus 70 millivolt, right? So now it will decrease to minus 35. right? So what was it earlier? Now this is the critical phase, and you will get understand from this thing only how this thing will takes place. Oh my god, right? So it was earlier minus 70 millivolt, right? It was earlier minus 70 millivolt. Now it will going to turn into more positive because our sodium channels are what? Sodium ions are positive. Sodium ions are positive, so there will be more positive over here, and the membrane potential will decrease to how much? Minus 35. So minus 70 to minus 35. So minus 35 is what? Minus 35 is the threshold potential. So threshold potential is the potential by which your voltage gated ion channels are open. I don't know why these technical issues are happening. This should not be done. It's worrying me also. I'm so sorry for that. So now what will you open? The voltage gated ion channels. So voltage gated sodium channels will open now. So after the opening of these voltage gated sodium channels, the more number of sodium channels will come inside, right? Because there are a lot of sodium channels present in the axon only. So there are a lot of sodium channels will come inside, and the sodium ions will come over here, and it will move towards very positive, right? So it will move towards very positive. So what is this process? In the process of threshold potential, it is achieving minus 35, right? So it is going to be depolarized. Got my point? So when this process is happened, when there will be more less negative, right? So the transform from the minus 70 to minus 35 is known as the depolarization. Now it is moving towards more positive because the positive ions are increasing, and when the positive ions are increasing over here, then the amount will be plus 50 millivolt because there will be positive number of positive ions will be increased, and it is called as the action potential. So now the action potential is happening. So when the action potential will be happening, it will open, you will convert it to plus 50, right? When this process is going on, it is going to open the calcium channel over here, right? So calcium channel over here. So calcium channels helps in the synaptic valve to release its neurotransmitter to outside, right? What is did the earlier presynaptic cell. So now this cell will be a presynaptic cell, and the forward cell will be a postsynaptic cell, right? Got my point? So now, oh my god, I don't know why it is not working. Okay, so now it is the cell we are showing. The calcium channel will be open, and the synaptic vesicles will fuses outside and releases its neurotransmitters to outside again, and there will be another neuron, there will be another neuron, and this another neuron will accept these neurotransmitters, and this will transfer the signal to another neuron, right? So by this process, one neuron will react to it, one neuron will interact with another neuron by the help of this synaptic clip. So I hope this thing is clear to everyone, guys. So let me summarize this thing again. So there will be a presynaptic cell, and there is be a postsynaptic cell. So presynaptic cell will release the neurotransmitter, and the postsynaptic cell will accept the neurotransmitter. So by the help of the receptor, and which is a sodium channel, right? So it is a sodium ion channel only, right? So this channel will activate the, it will cause the depolarization, and make the depolarization, right? So when the depolarization will occur, then after more and more number of sodium channels will occur in the axon, and there will be the opening of voltage gated ion channel, right? So now the voltage gated ion channels are open. First the receptor is act as ion channel and it will open the sodium inside the cells. Now the voltage is low. Now the voltage is turned to minus 35, and these sodium channels inside throughout the axons will open, and it will make to the axon potential, which will be of plus 50 millivolt. When there will be the axon potential, and then the calcium channel will be opened, and the movement of calcium inside the synaptic bulb, and the synaptic bulb release out the neurotransmitter, and that neurotransmitter will go and bind with another neuron, and there will be conduction of this process. I hope this thing is clear to everyone. So guys, there is some technical issue, so that I am not carry forwarding this topic. So I'll definitely teach this topic another time, and I hope this thing is clear to everyone. I made clear every point how this process is going on, how this membrane potential will change by the help of the sodium ion only, right? I hope you guys will like this. If at all you will like this video, please like it, share, subscribe with your friends, and if at all you want to join our IIT JAM Plus platform, then you have to take a subscription by which you will get daily live classes, structured courses, live test and quizzes, unlimited access, and this much is the price range. But if you using my code, that is my name, Debasish, then you will get a 10% discount, and after that for 1 month you will get 1800, 3 months 4500, 6 months 7200, 12 months 9000, 24 months 10800. And if you have the credits, then use these credits, and don't forget to use this code Debasish. So, and please like this video, like the channel, share with your friends, subscribe the channel. Thank you so much. Take care of yourself guys. Bye bye. See you again.